there. This is exactly what the whole unit is going to look like. Today we're doing day one, so understand the structure of the real number system and apply properties of real numbers to expressions and equations. Okay? Oops, if I'm on the right thing. Okay, so first up we have the complex number system. There's a lot of writing today. I'm just going to apologize in advance. Get your hand ready for lots of writing. So first up, we have complex numbers. Okay, within the complex numbers, you have real numbers and imaginary numbers. Okay, the real number system is broken down into rational numbers, which is any number in the form of p over q, where p and q are integers and q does not equal 0, which you can't divide by 0, plus q. The real numbers also include all irrational numbers, so non-repeating, non-terminating decimals. Does anybody know what a non-terminating decimal is? It goes on forever, it never stops. Does anybody know an example of a decimal that never stops? Pi. Anybody know another one? Well, square root of 2. And square root of 13. Lots of examples there. Okay, some rational numbers could be like 3, or 12 divided by 6, which is equivalent to what? 2, good. Or you could have some negatives, like -5/2. Include decimals, like 0.25 or 0.3 repeating. Those would all be considered rational numbers. And then your irrational numbers can be broken down into 3 categories. The natural numbers, like 1, 2, 3, and 4, so on and so forth. You have whole numbers, which adds 0 to that list. what numbers are we missing? Do you think? Negatives, yep. So our last one is integers, which is what includes the negative numbers. Okay, so now that we've talked about all the different kinds of numbers, I want you to read that next statement. And determine if that is true or false. So if a number is a rational number, then it is a real number. Is that true or is that false? It's true. I agree. Okay, let's read the directions though. It says then write the converse of the statement and determine if the converse of that statement is true or false. Do you remember converse from Miss Lashley's class last year? Everyone's favorite? Okay, what is a converse statement? It's where you switch them, right? So the converse of this one would be, if it is a real number, then the number is rational. So if a number is real, then it is rational. It's the converse. Hey, is that a true statement or a false statement? False. Agreed. That one is not true. That would be false. Okay? I want you to do the same thing for number 2 and number 3. Anybody else like starving, ready for lunch? And it's not until 1:15 today, in case you're wondering. Whew, we can make it. If you need to get out a snack or like half of your lunch and eat it now, I will not judge you. Just so you know, you're welcome to do that. All right, so number 2, if a number is real, then it is rational. Hey, we just answered that question, it was false, right? So the converse of that is gonna be what we had in number 1, which we said was true. What about number 3? If a number is an integer, is it a whole number? No. But if a number is whole, is it an integer? Yes. You sure wondering that was wrong on my paper, I had to fix it. All right. So next up is the closure property. It's on the back of this first page. And I will tell you that you can abbreviate on your notes. You can abbreviate. They're your notes, you can abbreviate. I know Ms. Lashley probably did not let you abbreviate, okay, but they're your notes. They're for you. You can abbreviate, all right? We'll talk about it on homework, but for the record, you can abbreviate. The closure properties, or property, a set of numbers is said to be closed for a specific mathematical operation if the result obtained is performed on any two numbers in the set and is itself a member of the set. Probably means nothing to you as you're writing it. You're probably just hearing wah, wah, wah. But I still want you to write it. Okay, so what all of those words that you just wrote down mean is that, for example, part A, it says negative integers for addition. That means if I add two negative integers together, then I get another negative integer if it fits under closure, okay? So, I'm gonna find someone. Grace, give me a negative number. -7. Okay. Stone, give me another negative number. -3. So -7 plus -3 is what, like, yes, negative. Yep, -10. So when I added two negative numbers together, did I get another negative number? Yes. Will that always happen? No? It will, okay? Unless you can think of a counterexample that I can't. So the answer is yes. It's closed. Because any two negative numbers added will give you another negative number. Okay, so let's try the same thing for negative integers. So, go with Anna. Can you give me a negative number? -5 times, let's see, Jennifer. Give me another negative. -4. What is -5 times -4, Spencer? Positive 20, okay? So, was a negative times a negative another negative? No, so this one does not work for closure. Because a negative times a negative gives you a positive answer. So as you probably remember from geometry, negative 5 times negative 4 equals 20 is called a counter example. So Ashley would be so excited that we're using those words again. Okay? So I want you to go ahead and try part C and part B without me. Remember, you're going to give me a yes or no, explain why, and if you say no, you have to give a counter example. So lots of good examples and counter examples, but you want to make sure you're explaining in your words why you say yes or no. Would anybody like to volunteer what they said on part C? They said yes or no?
My first answer is yes, minus 2 equals 4, but then I said no because 5 minus 7 equals negative 4. If the number that is being subtracted is equal to 4
Exactly, okay? So her first example, she said was 2 equals 3. Well, that would be closed, right? Because 3 is still a positive integer, right? But if she switched it, she realized she would get a negative number, so then it wouldn't be a positive integer, okay? So she said no, because if you're subtracting a bigger number from a smaller number, it's not closed. Completely agree. Very nice. Thank you. Okay, does anybody else want to volunteer for part D? Yes or no? What if I tell you the answer? Will somebody tell me why? Well, numbers is yes. Anybody want to give their explanation? Really? You're gonna make me pick on somebody? It's not right. Let's see. Joy, did you have an explanation on part B?
My example was plus now equals -10. I said yes because any two numbers are
Exactly. Any two whole numbers added are gonna give you another whole number. Thank you. Okay, now we have the commutative property. You've probably seen this before. Does anybody remember what that is? What is it? Oh, okay, means to change your swap. You can rearrange things and it doesn't change your answer. So in example A, we have 5 plus 3 in parentheses plus 2 equals 2 plus 5 plus 3 in parentheses. Says determine if the following equations demonstrate the commutative property, but an equation does not explain why, okay? So let's just do this, let's see what happens. What am I gonna do first on the left side of this equation? 5 and 3, because you start with parentheses, right? Order of operations, what is 5 plus 3? 8. Okay, I'm gonna simplify the left side all the way down first. What's 8 plus 2? 10. Not your favorite math, so only so much. Alright, same thing on the right side. Start within the parentheses. 5 plus 3 is still 8. And 2 plus 8 is still 10, right? So does that work for the commutative property? Yes. Alright, go ahead and do the next 3. Part C, did you say yes or no? Not part C, I lied, part B, sorry, part B, yes or no? Yes. Part C? No, why not? What happened? Were they equal? No, why not? Division is not commutative, it doesn't work when you switch them, 9 divided by 3 is not the same as 3 divided by 9. What about part D? Yes, okay, so it works with addition, it works with multiplication. It did not work with division, do you think it works with subtraction? No. Alright, associative property. Associative property means you can add or multiply regardless of how numbers are grouped. Okay, for these 4 examples, determine if the following equations demonstrate the associative property. If it does not, explain why. Notice you get to explain why all the time. Okay, so part A, left side. How do I simplify that expression? How do I get rid of these parentheses? Yep, you distribute the sign, right? So that would be 5 minus 2x minus 4. Can I combine anything there? What is 5 minus 4? What? On the left side, we have 1 minus 2x. On the right side, what happens? Do I distribute anything in those parentheses? I mean, technically, I distribute a 1, but they can really just go away, right? When I combine my like terms, what do I get? 9 minus 2x. So are they the same? No. So does the associative property work for part A? No, because we have some subtraction in there, which doesn't work with the commutative property or anything like that. So when you have multiple operations within a problem, here's my explanation to you. I'm not gonna write it. It'll be faster if you write it. When you have multiple operations in one problem, the associative property does not work. Go ahead and work those next 3. For part B, I hope you got that 16 equals 16, so that one is a yes. Part C, I hope you got that 54 equals 54, so that one was a yes. Part D, I hope you got that 0 equals 0, so it's also a yes. Any questions on the associative property? Now we have the distributive property, my personal favorite, because we use it all the time. We've already talked about it once today. It's used to multiply a single term and two or more terms inside a set of parentheses. I believe you drive to school, you may want to get gas on your way home, because apparently they're shutting down oil refineries in Houston because of the hurricane, so gas prices will probably go up. Throw that out there. You want to get gas on the way home, or tell your parents to get gas on the way home. I have to get gas on the way home. Okay, so it says simplify each of the following expressions by applying the distributive property. Combine like terms. If it cannot be applied, explain why. Okay, I'm gonna let you guys do all four of those up. Part A, did you get 3x minus 6y? Good. Okay, part B is a little tricky with all those negatives. So I'm gonna put it in standard form. -3 minus 1 is -4w. 15 plus 3 is 18. Okay. Am I using the distributive property on part C? Yes, no? Can you? Do you have to? No. Okay. If I was working this problem, I probably wouldn't. I would probably add the 3 plus 2 first and then multiply by 5, which would not be the distributive property. But you can. So if I was, I would do 15 plus 10 minus 14 plus 18. Which I hope gives you 29, because that's what I got. That's what you got? Yes. Okay. If I worked it the other way, that would be 5 times 5 minus 2 times -2. 25 plus 4 still gives you 29. Okay, what about part D? Right here we would multiply, right, to get 6w minus 3w. Just 3w. Did I use the distributive property? Why not? I multiplied. There are 2 terms that says 2 or more terms. Technically, this one is a no. So we did not multiply 2 or more terms inside the parentheses. Okay, I just want to apologize for the next page. I'm gonna give you some geometry proofs, flashbacks. So that was not your favorite thing in geometry. I hated proofs when I taught geometry. I feel your pain. I apologize for what we're about to endure. Okay, okay. Okay, the inverse property for addition. If the sum of a number and its negative number is 0, then it's called the inverse property of addition. Okay, so for example, Cam, what's your favorite number? 1, alright? So if I do 1 plus -1, then give me 0. That is an example of the inverse property of addition. Okay, what do we use when we don't know what number it is? You're writing an equation and you don't know the number you use, somebody said x. So x plus -x will always give you 0. Inverse property for addition. Okay. Inverse for multiplication. The product of a number and its reciprocal is 1. Well, the inverse property of multiplication. 3. Okay, so 3 times what is gonna give me 1? Anybody? Numbers. Okay, what about x times what is gonna give me 1? 1 over x. No. Okay, so that's inverse. It's the opposite of whatever you're talking about. Identity property, here's the geometry flashback, is for addition, is 0 added to any number is itself. So Nathan, what's your favorite number? 11. So 11 plus 0 is still gonna give you 11. Isn't this crazy? That's the craziest math you've ever heard in your life. Okay. Same for x. X plus 0 is still gonna give you x. Okay. What number do you multiply by to get the same number? 1. 1 multiplied by any number is itself. Ivan, what's your favorite number? 17? Oh, 18, sorry. So 18 multiplied by 1 is still gonna give you 18. X multiplied by 1 is still gonna give you x. And the last one should look familiar, right? I know Ms. Lash has talked about the substitution property of equality. If x equals y, then x can be substituted in for y in any equation. So if x equals 2, and I give you the expression 2x plus 3, what would you do? Plug it in. Plug 2 in for x. Is that what you get? Hopefully you should get what? 2 times 2 is 4, plus 3 is 7. Can you resolve this one? Okay. So they've done the math for us. Now we're gonna name the property that's used to justify each step, okay? This is where I'm gonna be different from Ms. Lashley. Okay, you do not have to write out property of whatever, okay? If it's the distributed property, you can put distributed. If it's commutative, you can put commutative, right? You don't have to put property of equality, property of whatever, okay? So what happens between this original problem and this step right here? How did we get from one to the next? The distributive properties. I will put all of the words, you do not have to put all of the words if you don't want to. Again, on your notes, you can put whatever you want on your notes. Okay? What about what happened between this step and this one? Simplify? It looks more complex to me. What do they do? They rearrange them, right? Didn't they put all the X's right here and the numbers right here? Which property was that? What? Commutative, somebody said it. A commutative property. It's when they rearrange things. What happened between the next step? What? Associative? Yeah, I disagree. I just wanna know what happened. What'd they do? They took out the X. Does everybody remember what that's called for number one? Factoring, okay? Mark Sparks called it reverse distribution, which I say because they use that term on the homework. Okay, I would have called it factoring, he calls it reverse distribution. Okay, this next one is gonna be different than your geometry answer, because what would your geometry answer be for the next step here? Simplify, right? But Mark Sparks, he called that substitution. Because what he's saying is you can substitute -6 minus 4 plus 11 for 1, because those equal the same thing. You can substitute 9 plus 20 minus 29 for 0, because they are the same thing, they are equal. So what do you think he's gonna call the next step? Identity property of addition. Okay, so in this one, you can leave out the property, you can just say identity of addition. I don't care, just make sure you clarify that it's addition and not multiplication. Let's look at that last one. Identity property of multiplication. Because 1 times anything is itself. Your hand hurt yet? No? No one's hurt. I was writing this, I was like, so none of my hand hurts. What was it? Alright, our last page of notes. Aren't you excited? So great. And I'm gonna let you do it without me. I want you to read, follow the instructions, and then do what it asks. In case you're wondering, there's only 12 minutes to lunch. Been really worried about that. two up at the top, they want you to plug in. So like right here, x equals -1, you're plugging it in here and here. And solving order of operations to get your answer. Same thing over here, plugging in A and B. Here, they want you to take this expression and simplify it first before you plug anything in. So on this box, they would want you to first distribute, combine like terms, and then plug everything in. Because you're doing the same math, it should give you the same answer both ways. Two questions on the left should give you 6 as your answer. Two questions on the right should give you 4 as your answer. So why does that happen? Why can we plug it in first and get one answer, and then we simplify it first and then plug in the same answer? Why does that work? I had a really hard time putting this into words too, so don't feel bad. Okay. I think the correct answer here would be just to say that it's using all of those properties we just talked about and all of that writing you just did. Okay? You're using the commutative property and the distributive property. You're not changing anything about your expression. You're just rewriting it in a way that makes more sense, right? So because you're using all those things we just wrote about, that's why that works. And that is finally the end of the notes for today. So what that means is you will have the 20 minutes when we come back from lunch to work on your homework, which is that green paper, front and back. If you want to finish it, or if you end up finishing it in those 20 minutes and you want to turn it in and then you have no math homework, fabulous. I will take it, no big deal, okay? I do want to clarify that I need you to read the directions, okay? If it says provide a counterexample, you're gonna have to provide a counterexample. If it says explain, you're gonna have to explain, or else I'll hand it right back to you and say try again, okay? And please write where I can read it. And then on those last ones in the box, you don't have to put property or spell out all of the words exactly. If you just want to put the word distributive, I'll take that. Please don't abbreviate that one, but I'll take just the word distributive, just the word substitution. Okay. And we finally get to eat lunch in 2 minutes.